It's space weather! And in 171 angstroms, we see Sunspot 2733 bursting into existence, and a little bit of X-ray activity. Check it out. Here at 193 angstroms, we see the coronal hole, as well as the sunspot rotating in and another active region right behind it. Here's a picture of the umbra, which has grown in complexity in the last couple hours. And it's going to be another beta class sunspot group. We'll see if this area incoming back here is going to turn into a sunspot also. And here are your magnetic field force lines. And they're looking a little bit anomalous today. Let's move on. At the real-time solar wind, looks like we got a heaping helping of missing data here. So let's see, the phi angle is way up around 315. We've got a highly positive BZ here, and the BT is actually very high too. Solar wind density incredibly low at 1.05 protons per cubic centimeter, and solar wind speed all the way down to 313 kilometers per second. Next, let's look at spaceweathernews.com. We see a tiny little X-ray flux occurring right now, possibly trying to make it into the B-class range. Oh, not quite. Oh, yes, it did. We had a B-class flare, barely. Magnetometer, there's your magnetometer. Pretty smooth right now. KP index back to 1. Electron flux still dipping down, surprisingly. I forecast this to go up today. And here's this anomalous F2 layer again. Got a very charged area down there, down south of South America. And there's your aurora forecast, extremely weak. Next, let's see what's going on in the magnetic situation by looking at the Gong 2. Alright, now, this incoming negative charge area, let me stop that. So, this area right here is a very strong set of fields. As you can see, they go almost straight into the corona, and they don't bunch up or anything. This is an indication of a very direct magnetic connection there. And you can see that the Earth to Sun connection here is taking its time making it over to this void here. So we're keeping an eye on that. Also, I'd have you note that this region is fluctuating a lot, and you can see it from the animation. And it's actually pushing this positive field even more than it's already pushed. So just watch that thing oscillate. You see that magnetic area there could change at a moment's notice with no warning. So we're keeping an eye on that. The Gong 2. Next, earthquakes at quake.globalincidentmap.com. The last 13 hours, we've got a 4.8 in Chile at depth. Chile should remain on alert for a 5. A 6.0 in Indonesia, 4.9 in Indonesia, 4.6 in Chile, 4.5 in Indonesia, so uptick going on in Indonesia right now, 4.8 in Indonesia, 4.9 in Taiwan. Here's the biggest quake of the past 24 hours, I believe, a 6.4 in Indonesia. And I clicked on the wrong one there. There we go, a little swarm going on. No tsunami generated from that. We did look it up. Also a 4.9 off the coast of Portugal, way out in the Atlantic Ocean. And there's where that one is located. Looks like it's just north of the Azores. Checking out volcanoes at volcanodiscovery.com. Alright, so we got Shivaluch is still explosively erupting, emitting a 14,000 and a 20,000 foot ash plume. Also, we've got Abico with a 9,000 foot volcanic ash plume. Tucono, 7,000 foot ash plume. Fuego, possible new emissions. Revenador, 14,000 foot ash plume. Moving on. Next, we've got some Magnetosphere movies for you. Looking at an extremely weak Magnetosphere once again, because the solar wind is so low. Here's the velocity. Here's the density, which is going to drop down very low right at the end. As again, the solar wind density is currently only at 1 proton per cubic centimeter. And here's the pressure. Looking weak. Very low pressure. Looks like a slight angle of attack change on the pressure also. Something else to note. Here are your geospace magnetic perturbations. Not very many perturbations going on. Almost entirely at the South Pole. Corroborating the data about very weak auroras. Let's look at how it spans the globe. Indeed, not a lot of perturbations at all. So geospace is pretty quiet. Let's do a quick cosmic ray rundown. We will leave links to this great Cosmic Ray Links website. First, Athens. We're going to see an upgoing trend here. Athens is at the highest levels that it's been for the entire month. Check it out. Check out that uptrend. Last we checked, Mexico City does not agree, although we still do see an uptrend in the past week or so. Moscow shows an even more significant uptick. You can see from about the 10th of January up until now, pretty significant uptrend there. Next, let's look at Oulu, which is also showing an uptrend, but a much more minor one. DOMC Antarctica, not really an uptrend there, but we did see that large spike on the 16th. And DOMB Antarctica, is showing a similar uptrend. So we're seeing that across most boards. I'd like to draw your attention to one more thing here. The OLU monitor, like some of the other ones out there, has the ability to query other data. So let's go all the way back to 1964. Generate chart, just so you have an idea of what the historic cosmic ray levels on Earth have been. And there you have it. Now you can see we are currently at the second highest levels ever measured. But the highest levels ever measured were here around 2010 at OLU. The current levels have indeed exceeded the 1987 maximum and all other measured maximums at OLU. Next, we've got an article attempting to explain what's going on in the outer solar system. Where's all the gravity coming from, people? Where's it coming from? Is it Nibiru? Is it Planet X? Is it Nemesis? No. No. The theory is that it's the combined gravitational force of a bunch of small objects beyond Neptune. So, yeah. Not any kind of a new theory here. We just thought we'd put up the article to anger Planet X, Nibiru, and Nemesis people. Links to the article in the description. Next, let's look at a phys.org article. K2-22b, an exoplanet slightly smaller than Neptune. Apparently the planet's disintegrating. It's leaving a trail of dust behind it and following a trail of dust. So, interesting article. Not exactly sure the physics behind it. And yeah, I don't think anybody knows the physics. They were just surprised to find the dust behaving the way it was. Next, how about an article on Science Alert about Sagittarius A star? Turns out one of Sagittarius A star's relativistic jets may be pointing right at our solar system. Now, this is an odd situation. This article raises the possibility that Sagittarius A star is laying on its side. And that's one of the reasons why the jets is pointing somewhere toward Earth, perhaps. Anyway, interesting article. Have yourself a read if you're interested in galactic scale cosmology. How about a little 304 angstroms? If anybody's got an alternative name for Sunspot 2733, please put it in the comments. We're sticking with Sunspot 2733. I think it's a great name. It's really catchy. And let's zoom out and see if there's any interesting filament activity going on. Hey, thanks for watching, everybody. It's about time to wrap this up and get it on the web. Please don't forget to like and subscribe if you enjoy the content and share on your social media. Remember, when you're staring at sunspots at the moment of their birth, don't drink. And if you drink, stare at sunspots at the moment of their birth anyway. And don't drive.